Hannah Thomas Gonzalez, a systems engineering major, and I wanted to talk to you about Six Sigma. Six Sigma is structured and it's a data-driven approach to improving processes by reducing variation and by preventing defects. It's widely used across industries because it delivers outcomes engineers care about: reliability, predictability, and cost reduction. Statistically, Six Sigma means designing a process so that the mean is 6 standard deviations away from the nearest specification limit. In practice, it's not about hitting a number, it's understanding process capability and designing systems that remain stable under real world variation. For example, a process with a CP greater than 1 might look capable, but if it's off-centered, the yield will still suffer. That's where CPK matters. It tells you whether the process is both capable and correctly centered. Without jargon, Six Sigma allows us to define the actual failure mode, measure baseline performance using data and analysis of root causes, improve the system itself rather than patching individual issues, and control the process so that gains are sustained throughout monitoring and feedback. The logic is already familiar to engineers. It's the same mindset used in debugging, system optimization, and designing iteration, just applied systematically and statistically. The most common framework is DMAIC, which improves existing procedures and processes by addressing root causes. For systems that are new, DMADV is used to ensure its potential is great before actually implementing it. In the end, Six Sigma isn't limited to manufacturing. It applies to improving system reliability, reducing variability in schedules, and optimizing workflows, often in combination with lean principles that focus on eliminating waste and increasing predictability. The key takeaway is that Six Sigma isn't about achieving zero defects because it's impossible. It's about building processes that are statistically predictable and stable despite any uncertainty. In other words, engineering discipline applied to variation. Thank you.